वेलकम टू आवर चैनल वी ऑलवेज लर्नर। इस वीडियो में हम आपको सिस्टम एनालिसिस को अंडरस्टैंड करने में हेल्प करेंगे विद द हेल्प ऑफ फोरियर ट्रांसफॉर्म। जब हम फोरियर ट्रांसफॉर्म यूज़ करते हैं तो हमें सिस्टम को अंडरस्टैंड करना पड़ता है फ्रीक्वेंसी डोमेन में। तो उसको अंडरस्टैंड करने के लिए हमने ये वीडियो बनाया है। आपको ये वीडियो पसंद आएगा, आप लाइक करिए, शेयर करिएगा, चैनल को सब्सक्राइब करिएगा और बेल दबाना मत। तो कोई भी LTI सिस्टम, कंटिन्यूस टाइम सिस्टम अगर हमारे पास गिवन है और उसमें कुछ इनपुट अवेलेबल है और कुछ आउटपुट भी अवेलेबल है। सो सपोज हम एक ब्लॉक डायग्राम के थ्रू एक सिस्टम को रिप्रेजेंट करते हैं। यहाँ पर देयर इज इनपुट एंड करस्पॉन्डिंगली वी आर हैविंग द आउटपुट। इनपुट को हम मानते हैं xt और आउटपुट वी आर एज्यूमिंग दैट yt इज ए आउटपुट, and we are representing ht as a impulse response of the system. Now we can have the output by yt. So yt can be expressed as the convolution of the sequences x and h t minus tau. That is, by definition of convolution we can directly write this equation. Now we can also, using the commutative property of the convolution, we can write it like h of tau and x t minus tau. So we can also write it like this. So this is equal. Now we can also assume here that our input for the system is e raised to the power j omega t, which is a complex exponential signal. Now we have to compute the output yt if x is given by a complex exponential signal. So we have to put h tau and x is in terms of e raised to the power j omega, that is t minus tau d tau. So that is how we can represent it. Now we have to integrate with respect to tau, so we can take e raised to the power j omega and t common or outside the integral. So we can write it like integration of h e raised to the power minus j omega tau d tau. So now we know that by definition of Fourier transform that h j omega can be expressed as integration of h tau e raised to the power minus j omega tau d tau. Now we can put this value into this equation and we will reaching up to a point where we can get the yt by this equation by putting the value, and that is equal to yt. Now e raised to the power j omega, here we can call it eigenfunction of the system, and h j omega is called to be as eigenvalue. They called to be as eigenvalue. Now let us represent the term h j omega as the magnitude response, and also we can also represent the angle h j omega as a phase response. Now to find out the value of h omega for a system, we have to have the representation for a LTI system, and that is described by the constant coefficient differential equation, that is summation k is equal to 0 to capital N, the kth derivative of y t, that is equal to summation k is equal to 0 to m. bk's are the coefficient and here ak's are the coefficients, and the kth derivative of x. So that's how we can define a system. So now by substituting the values of y and value of x, we can get summation k is equal to 0 to capital N ak, the kth derivative of the function y, which is represented by e raised to the power j omega. So by one equation we can write e raised to the power j omega t, and h j omega we can represent it like this. So that is equal to summation k is equal to 0 to m bk, the kth derivative of x, where x is e raised to the power j omega t. By equation number 2 we can have it. So from that we can write h j omega common to that, and we can write summation k is equal to 0 to capital N ak. Now this function can be written as kth derivative of e raised to the power j omega t is equal to summation of k is equal to 0 to capital M bk, the kth derivative of e raised to the power j omega t. That's how we can write. Now in the next step we can do the h j omega, we can take the derivative k is equal to 0 to capital N ak, the derivative of this is j omega, and here we can write e raised to the power j omega t. And this is the kth derivative, so we can make it like this, and summation k is equal to 0 to m bk. Now the kth derivative of e raised to the power term, this will be give j omega raised to the power k and e raised to the power j omega t. That's how we can express it. Now we can find out the value of h j omega, that is equal to summation n is equal to 0 to capital N bk j omega raised to the power k, divide the complete term by summation n is equal to 0 to capital N ak j omega raised to the power k. So that is, we are going to have the h in frequency domain. So using the convolution property, we can write that the convolution of x and h in time domain will give the multiplication in frequency domain. So we can represent by using convolution property. can write it like this. Now we can say that hj omega is equal to y j omega, that is divided by xj omega. So we can write like this. Now the y, h and h, y, x and h are the Fourier transform of x, y and h, which is a function of time. So we can also express this by this equation, and we can write with different color here. So that is equal to y j omega divided by x j omega. So we can express it like this, and this result will give us the response into the frequency domain, right? So that's how we can calculate and we can analyze the system, and we can have the response of the system in frequency domain for a exponential input signal. So hope you like the video. Please subscribe the channel and do not forget to press the bell icon.